Approximation of the function cube root of 1 plus x. So first of all, linear approximation means find the equation of the tangent line. So it's just another way to say that. And we're doing this at a equals 0, so that's the x coordinate of our point of tangency, and use it to approximate the cube root of 0.95 and the cube root of 1.1. Okay, so first thing we need to do is find the tangent line equation. So as per usual, we need a point and we need a slope. So the point is at a equals 0, and we're going to have to figure out what the corresponding y value is. G of 0, that's the cube root of 1 plus 0, or the cube root of 1, which is 1. So the point is 0, 1. Then the slope is g prime evaluated at the point of tangency, so at that a equals 0. So we need to find g prime of x, and I don't know if everybody understands, the cube root is the same as power of 1/3, right? So I could write my g of x as 1 plus x raised to the 1/3 power. So g prime of x, using the chain rule, I bring my power 1/3 down. I rewrite my base function to one lower power, and 1/3 minus 1 is negative 2/3. And then I multiply that by the derivative of the base function, which in this case is 1. And now I want to evaluate that. I'm not really so concerned about writing it in a certain form. I really want to evaluate it at x equals 0. So I have 1/3 times 1 plus 0 to the negative 2/3. And of course, 1 to the negative 2/3 power is still going to be 1. So my slope is 1/3. Pardon me. Sorry about that. All right, so my tangent line equation, I'll use L of x as the book is doing, L for linearization, is my g of 0, which is 1. Well, here, let me write it in general form first. So this is going to be g of 0 plus g prime of 0 times x minus 0, right? That's equivalent to the earlier forms we saw on the handout, f of a plus f prime of a times x minus a. So in this case, my g of 0 is 1, g prime of 0 is 1/3, and of course x minus 0 is just x. So I don't really have to write the minus 0 anymore, but I'm going to write this in simplest form anyway. That is 1/3 x plus 1. So I put it in mx plus b form. Now what that means is, for x near 0, this cube root of 1 plus x, that was the original function, is approximately equal to 1/3 x plus 1. In other words, if I stay close to the tangent point, then the value on the function is going to be almost the same as the value on the tangent line. Okay, now, they asked us to approximate the cube root of 0.95 and the cube root of 1.1. So let's do that part. If we want to approximate the cube root of 0.95, first of all, the cube root of 0.95, I got to figure out what my x is. That is the cube root of 1 plus x. Okay, so that's the function that I can approximate with this tangent line. And so that means if 0.95 is 1 plus x, then that means x is actually negative 0.05. So in other words, if I subtract 0.05 from 1, I get 0.95. So the cube root of 0.95, that is g of x, is approximately equal to 1/3 times x, which is negative 0.05, plus 1. Now, you should put that into your calculator, and you should get 0.983 with the 3 repeating, of course. And then, just again, to check this out, either in Mathematica or on your calculator, you can, of course, take the cube root of 0.95, and according to the calculator, that's 0.98305, at least to that many decimal places. So you see that these are approximately equal. In other words, if I use the tangent line equation to come up with the value, or I use the actual function, which I can do because I have a calculator, they're approximately the same. So you see how that works and that it is working. All right, let's try the cube root of 1.1. Right, and again, relating what's under the square root to 1 plus x, that means my x value is 0.1. In other words, if I take 1 plus 0.1, I get the 1.1. So my tangent line value at 0.1 is 1/3 times 0.1 plus 1, which, again, if you put that into your calculator, that's 1.03 with the 3 repeating. And this linearization then says that the cube root of 1.1 should be approximately equal to the linearization, the tangent line value of evaluated at 0.1. So if you do on your calculator, what is the cube root of 0.1? The cube root of 1.1, pardon me. It gives you 1.03228. Again, I would pause the video and do that on your own calculator just to make sure you're getting it. So again, these are approximately equal. So what we're doing is we're estimating a cube root value by using the tangent line. Now, you might be asking yourself, why do we even bother doing this? We all have calculators. But FYI, just so you know, when you ask your calculator to do a cube root or a square root, it's actually using an approximation, and it's not using the tangent line, it's using a higher order one, which if you go on to Calc 2, you'll learn about those. But in fact, calculators and computers are using approximations like this to do things like natural log, to do things like e to a power, to do things like cube root and square root. So these are being used in the background, even though you didn't realize it. Okay, now I made a couple graphs in Mathematica here. So again, I'll do some erasing in a minute. But if I count backwards here on the left side, the graph on the left along the horizontal, this spot right here is negative 0.05. So you can see that when we go up to, I have the tangent line in orange and the function in blue, and you can't tell them apart. But in the graph on the right, zoomed way in, right? Let's go back and look. On the tangent line, we would be on 0.983333333, 0.983 repeating. If we were on the actual function, we'd be at 0.98305. And again, my drawing is not totally accurate, but just to give you an idea. So the thing is, the difference between those two is so small, we have to be super zoomed in to be able to even see it, right? On the graph on the left, we can't tell the difference between the blue cube root function and the orange tangent line. When I zoom way in, like the graph on the right, then I can get a sense. Okay, and again, I'm just going to erase these so they don't muck everything up. Now, in this second graph, in the graph on the right, I only zoomed in at x equal negative 0.05, so I'm not seeing the part where x equals 0.1, but can do that over here. And again, hard to tell the difference in this zoomed in graph. But if I were to, in the unzoomed graph on the left, but if I were to zoom in there, then I would see the y value on the actual blue function is 1.03228. The y value on the orange tangent line would be 1.03 repeating.